Hello, so I'm just going to give you a real quick run through of how we can get from our simulation in Tinkercad to a PCB that's ready to manufacture. So first of all, what you'll need to do is you'll need to open up your project in Tinkercad. Now what I'm going to show you today is I'm just going to show you an example of how to do this, and you should be able to run through this and follow the steps, and that should work just fine with your own projects. So I'm going to show you an example from class that we did. So I'm going to pick this one over here. I'm going to pick the 555 timer because I think this is quite a nice example. So I'm going to load this up in Tinkercad. Now this isn't going to look exactly the same as when you do it, because I'm going to be doing this on a Chromebook. Now this is the only step that you need to do on a PC, and you need to make sure that you have Fusion 360 open and licensed. If you just have the temporary 30-day license for now, that's absolutely fine. You can still do this step, but make sure you've saved this in Fusion 360. I'm going to show you how to do that. So before we start, I just want to check that this is simulating properly, and remember you'll need to put screenshots of your circuit simulating into your assignment. So there we go, I can see this is working properly, my LED is flashing, and I can change this potentiometer over here, which acts just like a variable resistor, and I can see that the rate of flash changes because this capacitor is being discharged more slowly by this variable resistor. So brilliant, that works. I'm just going to check the circuit schematic here, and that all looks correct. And the reason I'm checking this is because I want to make sure that this looks the same when I open this in Fusion 360 in a moment. Now, next step is you need to click Send To, and you need to click Autodesk Fusion 360. Now, I'm not going to click this because this isn't going to work in on your Chromebook. You need to make sure you're doing this on a desktop PC. You need to make sure you have Fusion already open. Okay, so I'm just going to show you what that would look like once you've opened this in Fusion 360. And what will happen is this will come up over here. It will start with this page, and you should have both a schematic view here and a PCB layout on the right. So what I'm going to do, this is one I've just done, so this is the final step. I'm just going to show you how we can get to this step. So this is what it should look like when you've finished. So first of all, I want to make sure that you've saved your designs. So you need to go File, and you need to go down to Save. So click Save, make sure you're calling your project a sensible name, call it something like assignment, projects, assignment, sports counter, possibly even with your name, something like that, just to make sure you don't lose it, because we're going to have to come back to this. Okay, brilliant. So what I'm going to do on this one is I'm just going to start again. So I'm going to rip up all of the signals, and I am going to delete this trace right here. Brilliant. So this is what yours will look like. Now, this is how all of the components will be laid out on your PCB. And on this one, I've already moved them around. So what I've done is I've moved some components, and you can click the move tool up here. You can move them closer together or further apart. And so you can really lay out this how you would like. Now I'm going to make this slightly smaller because in engineering, we tend to like projects to be as small. Well, in electronics, certainly we generally are trying to make electronics as small as possible, especially if they're personal devices. So I'm just going to reduce the size of this board just by dragging around the edge. Now, you may find when you go to make all of your wires, or traces as they're known, those layers of copper on the PCB which conduct electricity, you may have to make this bigger to make sure it all works. Okay, so I'm just going to show you what we're looking at here. I'm going to switch to the 3D PCB view, and just press push this button down here, and what we'll be able to see is how the components are laid out in 3D on the circuit board. So I'm going to zoom in over there, and we can see all of the components laid out. Now this is really, it's just showing you exactly the same as what the PCB layout shows you, but it's just a little bit more clear. So I've got my potentiometer over here, my LED, my capacitor, 5 timer, resistors, and the battery pad is going to be this part over here with the positive and negative. Brilliant. So I'm just going to show you the bottom surface by clicking and dragging on this square in the top right corner. You can scroll the wheel of your mouse to zoom in, and we can see, that first of all, there's no traces on the board so far, but the pins of our components are coming through the board. So these are known as through-hole components. And we've just got these little pads of copper right here, which we will need to solder onto. So we'll need to make a connection between these pins and these solder pads right here. And we'll be doing that in task 2, when we actually go to make this board. Brilliant, so I'm just going to close that for now, and don't bother about saving it, because it's better to push to a new 3D view each time you change your PCB view, just so it keeps it updated. Okay, brilliant. So first thing I want you to do then is I want you to make sure the bottom there is selected, because actually we want to be creating our traces on the bottom there of this PCB. Now, I just want to quickly show you that you can quick route these air wires. So if you click there, what you've done is you've made a PCB trace from these white things, and these white things are called air wires, and they simply just show the program where the connections need to go. Now, if I was to push this to a PCB 3D view, which I think I will do quickly, you'll be able to see that that copper trace has just been created on the bottom side of the board. So let's zoom in again. And let's rotate this, and you can see right there that that copper trace has been made between those two pads connecting those two components. And if I can turn this board around, I can see what these components are. So that is a connection between my resistor and my integrated circuit here, which is my 5 timer. Okay, brilliant. So I'm going to go back to the PCB view. Now I don't actually need that. So what I'm going to do is I'm going to click over here, which says rip up. And I'm going to click the drop down menu, and I'm going to go to rip up all, and that should remove that trace right there. So I'm back to having an air wire here. Now what I'm actually going to do, and this is much, much faster, is I'm going to use the auto router. So first of all, we need to set this up so that we're not removing too much copper. Now we're actually going to be milling these boards, so that means the drill is going to have to run down, back and forth down the surface, and remove a layer of copper that's on the PCB board. So the PCB boards come, essentially the whole bottom side is coated in copper. So actually we don't need to remove that much, because it will take ages for the milling machine going back and forth. We don't have that much time. So what we're going to do is we're going to make it so that we just remove around the copper traces that we want to create. And to do that, we're going to use a rather clever trick. What we're going to do is we're going to click this polygon pour up here. We're going to make sure the corner style is set to right angles, so that's that one right there, and we're going to simply click all around. Now you need to make this polygon bigger than your PCB board, but this should do the edges for you automatically, and then click back up to the start. Now it's going to give you a name over here, and this says signal name. Now it's very important that you type this in as GND exactly, and that should come up as the ground signal for your connections. Now, if you zoom in, you can see that this ground signal has not gone to the edge of the board. However, I can see right here that it's actually not been connected to the battery 1 signal. So what I'm going to do is I'm going to quickly route that one. Okay, so actually we need to call it this. We need to call it bat1 minus. Okay, so I'm going to zoom out again. So we need to make sure it's the same name as the battery there. So what we're going to do is we're going to go on to okay, you know what, we're just going to delete that and do that again. I think that's going to be slightly easier. So click on the edges to delete this. I'm going to rip up this signal over here. Okay, rip that one up. Just click rip up all. Okay, I'm going to pull my polygon again. Once more, make sure it's the corner style is right angle, and it should be BAT capital letters 1 and then minus, no spaces. Okay, so click around the edge. There we go. I'm going to say BAT 1 and then minus, no spaces. I'm going to click OK. Okay, brilliant. Now I can see this has worked already. So I'm going to zoom in, and you can see that this copper trace has now connected to my battery minus over here. And you can see that air wire has disappeared where that doesn't need to be connected, because I can see that these two are already connected by this massive piece of copper, which is just acting as a wire. So I'm just going to push to PCB view, and I'm going to show you what I mean by that. Here we go. So I'm going to rotate it again, and we can see, there we go, that this copper there has filled the entire bottom of the board, and you can see that this pad is connected to that layer via these traces right here. Now these are a little bit too thin for us to mill, so actually what we need to do is we need to make those a little bit thicker. So close this. Don't need to save. And I need to change my design rule. So I'm going to click design rules / ERC up here, this tab, and I want to click this one here that says DRC with the tick. So what I'm going to do is I'm going to go to this tab that says clearance right here, and I'm going to change these to 0.5 millimeters. Now I've already done this, so you need to make sure you're doing this as well, but actually I can see I need to change these ones down here too. So make sure you double click, make sure you're in millimeters, not mils, they're actually different units. So 0.5 millimeters in each of them, and that should make our traces thicker. The only other one you need to do is you need to click on the sizes tab up here, and you need to go 0.5 millimeter for the minimum width of the traces themselves. Okay, if I press check here, that's going to give me an error because I know that none of the air wires are connected. That's fine, but this is going to be too small as well. That's fine. So I'm just going to click here, and I'm going to click apply. And close this off, and we should see that that has got slightly thicker. I'm going to go ahead and assume it has. Okay, brilliant. Now, next step we need to do then is we're actually not going to connect all of these signals one by one, and you can see that if I did here, what we've got now is we've got the milling machine is simply going to mill out around this trace rather than removing tons and tons of this copper there. Now, I can do these all individually if I want to, but actually I'm going to make this easier for myself, and I'm going to use the auto router. So I'm going to go where it says quick route in the drop down menu, and I'm going to press auto router right here. I'm going to make sure the top is selected to NA, and it's only the bottom layer that's on auto. Okay, so it should only be connecting traces on the bottom layer. So I'm going to press continue and press start. Now, once each of these has got to 100%, that means all of the air wires have been connected to signals. Now these vias just mean there's holes going between the top and the bottom layer. We're only going to be working on the bottom layer, so you need to make sure there's 0 vias as well. If you've got any vias, you've done something wrong, and you need to go back and make sure only the bottom layer is selected. So you can select any of these, it doesn't matter. These are just 4 different solutions. So I'm going to pick this one. I'm going to click end job, and we can see that this is all connected. Okay, brilliant. Now this has left a bit of copper blank over here, and I'm not sure I like that too much, but it's not too much, so I'm not too worried about that. But if it's a whole bunch of the board, I want you to go back and start again, because this will simply take too long to mill out. And I can see I've got one trace over here which doesn't seem to be connected. So actually that's a little bit of a problem. So this hasn't done as well as I like. So what I'm going to do is I'm going to rip up all, and I'm going to start again. And if I wanted to, I could even make sure I've changed the layout. So zoom into your components a little bit. You may want to move the order of them. It looks like this might be better off coming up here. Battery, I might move that down to there. This potentiometer. Okay, there's something interesting going on there. Okay. All right, let's try that. Let's see if that works any better. So I'm going to go quick route again, go to the auto router. Yep, all set up. I'm going to press start. Check this one. Let's get end job right there. And this, yep, this is looking quite a bit better. You can see it hasn't removed large swathes of copper that I want to keep, and it looks like these traces are intact as well. Brilliant. Okay, so there's no air wires, so this looks pretty good. I'm just going to have one last check on the 3D view to make sure this is all correct. I'm going to zoom in, and I'm going to look on the bottom side, and you can see there, brilliant, all of these traces are looking good, and you can see these ones are connected to this big ground copper trace, so that's looking good. Not too much copper to remove there. Brilliant, and looks like I've got a sensible layout on this side as well. Okay, great, I'm going to close that. Okay, now one last step then, and that will lead us into task 2 when we go to manufacture this project, but the assignment requires you to get a screenshot of what it calls an artwork output, and what you can do is you can go to Cam Preview over here, click Cam, so you need to go to the Manufacturing tab, Cam Preview, and then you need to click Cam down here. This is okay, brilliant. So what you need to do is, I'm going to cancel this for a moment. You need to make sure you're saving your document at this stage. Okay, so click Save. User saved, that's fine. Milestone, not particularly. You can click that if you want. Just click OK, and we'll come back, and we need to click Cam over here. And we want to go to where it says Gerber, this part here, and we want to be looking at the bottom there. And we can see right here that we've got a Gerber output, and this is known as the artwork view. Okay, so this, when our PCB gets milled on the PCB milling machine, this is going to be what it looks like. Brilliant. And later on, you don't need to do this right now, but we'll need to export this file, and then that's what we'll be importing into the software to create what's known as G-code, where we can manufacture a PCB. Okay, brilliant, guys. So that's it for now. Make sure that this is saved, and if you have any questions, please do ask me. Brilliant. Thank you very much.